So what is logarithmic integration? In integral calculus, some functions when integrated result in logarithmic expressions. One of the most common forms looks like this. Integral of 1 over x dx is equal to ln x plus c. We use this when the integrand resembles 1 over x, but it doesn't stop there. More generally, when you have an integral of the form integral of f prime of x over f of x dx, the result is ln f of x plus c. This is super useful because instead of doing u substitution every time, you can instantly integrate expressions where the numerator is the derivative of the denominator.
So our problem number 1 is the integral of 2x over x squared plus 1 raised to 3. So in this problem, we notice that the numerator is the derivative of the inner function in the denominator. So the denominator is equal to x squared plus 1. And the inner part of this is x squared plus 1, right? And the derivative of x squared plus 1 is 2x. So which matches the numerator. So this is a perfect case for u substitution. So we have to let u is equal to x squared plus 1, which du is equal to 2x dx. And if we are going to divide it both sides by 2x, so the 2x will be cancelled out. So dx is equal to du over 2x. So since we let u is equal to x squared plus 1, so right now, like, so diba, x squared is equals to u. So u will be right now cube. So the whole 2x dx is just du, and so this x squared plus 1 raised to 3 is equal to u cube. So now the integrals becomes the integral of du over u cube. To delete. Now we have to simplify and integrate. So our integral, right, is integral of du over u cube, and we can apply the power rule, which u n plus 1 over n plus 1 du, which u will be, we are going to raise it in numerator, it will become negative. The power will become negative. So plus 1 over negative plus 1 du. So it will become u raised to negative 2 over negative 2 plus c. So the answer will be negative 1 over 2u 2 plus c, and substitute back the value of u, which is negative 1 2 x squared plus 1 squared plus c. So this is now our final answer. Our second problem is the integral of 4x over 2x squared plus 3 raised to 5 dx. So first, we have to look inside the parentheses in the denominator, which is, the value of it is 2x squared plus 3. So it will become d over dx 2x squared plus 3, which is equal to 4x, right? So we'll be now using u substitution, which is u is equal to 2x squared plus 3 du is equal to 4x dx, and divide both sides by 4x. So 4x will be cancelled out. So right now dx is equal to du over 4x. So the integral will be, the value for that is we let the 2x squared plus 3, right? So 2x squared plus 3 is equal to u. So right here is there power 5, so it will become u raised to 5. So the integral becomes 1 over u raised to 5 du. So next is we have to integrate in terms of u. So in this case, we can use the power rule, which it will become u raised to negative 5 du. So u raised to negative 5 plus 1 over negative 5 plus 1 plus c. And it will become 1 over negative 5 plus 1 is equal to negative 4. So it will going to denominator because it raised to negative power. So negative 5 plus 1, so negative 4 u 4 plus c. And substitute back the value of u, which is the value is 2x squared plus 3. So it will become is equal to negative 1 4 2x squared plus 3 raised to 4 plus c. So this now is our final answer. So this is our problem number 3. So if we have a constant numerator, just factor it out and apply the rule. So our rule for here is if we have a constant numerator, so 1 over ax plus b dx is equal to 1 over a ln ax plus b, so plus c. And we start with this problem. So the integral of 8 over 3x minus 2. So factor the constant 8 outside the integral. So 8 integral of 1 over 3x minus 2 dx. So now apply the logarithmic rule. But let's focus on this, the 1 over 3x minus 2 dx. So using the formula above this rule, so what is our a? 1 over 3. Let's erase this first. So 1 over, what is our a here? So 3. ln a is 3 x minus 2 plus c. So since we have 8 here, so we have to multiply it. So it will become 8 over 3 ln 3x minus 2 plus c. So this will become our final answer. Problem number 4 is the integral of 6x plus 2 over 3x squared plus 2x plus 7 dx. So this is rational functions, meaning fractions with polynomials on top and bottom. So let's look closely. So our numerator is 6x plus 2 and our denominator is 3x squared plus 2x. So the question is, does the numerator look like the derivative of the denominator? So let's find out. Let u is equal to 3x squared plus 2x. And the derivative of this is 6x plus 2. So this is a perfect match. The numerator is exactly the derivative of the denominator. So here's a dx. Divide both sides by 6x squared plus 2. X squared plus 2. This will be cancelled out. So dx is equal to du over 6x plus 2. So right here, substitute the dx, the value of dx. So the value for dx is du over 6x plus 2, right? So this will be cancelled. So we know that we let the u, the value of 3x squared plus 2x plus 7. So this will become 1 over u. So this will be ln 3x squared plus 2x plus 7 plus c. So this will be our final answer. This is our problem number 5. The integral of 8x minus 5 over 4x squared minus 5x plus 6 dx. So this is the same process just like what we did earlier. So we want to check if the numerator is the derivative of the denominator. So let's find the derivative of the denominator. So let u is equal to 4x squared minus 5x plus 6 du will become, so 2 times 4 be 8x minus 5, so this is 5 plus 0. So is this match with the numerator? So yes, it's the same. So du is equal to 8x minus 5 dx. Divide both sides by 8x minus 5. 8x minus 5 is cancelled. So become dx is equal to du over 8x minus 5. Let's delete this. So we have to substitute it here. So this will become x minus 5 x squared minus 5x plus 6, multiplied it by du over 8x minus 5. Cancel that out. So we let the value for u is equal to 4x squared minus 5x plus 6, right? So this is become 1 over u, and 1 over u in the rule is equal to ln u plus c. So substitute the value for u, or this will become ln. The value for u is 4x squared minus 5x plus 6 plus c. So this is our final answer.